134, I believe it was. But anyway, this is not going to be on 134. This is to get your brains going to where we were. So, what? Oh, well, lucky you. You should actually be on 133 in your books, though, not 134. Because we're going to finish at the bottom there. Remember, I left all that blank white space. So, I've just been informed that that actual question is on there, so we'll make it that. Now,
do you know what question 7 was? Because I don't think we were finished it.
don't worry about it. You look at this and you say to yourself, self, is this a perfect square?
Yes.
Yes. Is this subtraction? Yes. Is this a perfect square?
Yes.
Yes. So that means we can do what we just learned yesterday. We take the square root of the first one. What is that? 4x. And we add the square root of the second one. What's that? 2y. And then we write it again with a minus.
Well, wait.
Okay? That is, we're just going to stop there for now. Okay? I'm just wanting to wake your brains up to the square root thing. Riley. Okay. All right. So let's do a really easy one. X squared minus 1. Is that a perfect square? Okay, so it's x, right? Is that a perfect square? So it's 1. Okay, now, plus, minus. If I expand this, x times x gets me x squared, yes? X times negative 1 gets me negative x, yes? X times positive 1 gets me positive x, yes? And 1 times negative 1 gets me minus 1. What happened right there? They disappear. So in order for there to be no middle term, I have to have plus and minus the same thing. Cool? Okay. Everybody can do this one, right? Everybody remembers, that's the basic rule. Everybody good? Okay. Now go back to 133, which is where we were, and we did these weirdo ones. We started with this guy, which wasn't a perfect square, was it? So we factored out an x, and then we got a perfect square, so we did it. Right? Everyone's cool? Then we went to this one, which looked like it might be a perfect square, because we saw x's with a bunch of numbers, x's with a bunch of numbers, and a minus. So we factored out our 10, but we ended up with x squared plus 8. Could we go any further there? No. Why? 8 has no perfect square. And then I said, what if I changed this to 90? Then it would have been x minus 9, and then we could have gone further. Was everybody good there? Okay. Then the bell rang here. We'd already seen this in other factoring we had done, right? This, what do those brackets do to x plus 7? It groups them together as one thing, yes? So I am allowed to call that one thing. So I am going to call that x plus 7. I'm going to call that the letter A. I can choose any letter I want. I can choose any symbol I want. Yes? So if that is A, I rewrite this as A squared minus 64. Now, does that look exactly like that? Yeah. So I take the square root of the first one, which is A, and I add the square root of the second one, which is 8. And then I write it again with minus 8, yes? Yeah. Now, is A actually anywhere in this question? No. No, because I'm the one that made A. So this A isn't anywhere in the question, but what do I write there instead? X plus 7. So I come down to here, and I have x plus 7 plus 8. And what do I have here? X plus 7 minus 8. What is 7 plus 8? X plus 15. And what is 7 minus 8? X minus 1. And that one's done. Is everybody good? Yeah? Okay, now there's only one more thing I can do with this. I lie, there's actually two. The first one is really simple. X to the 6th minus 4. Is that a perfect square? Why? Because 6 is 3 times 3. It's 3 plus 3. It's even, right? So can I get a square root of any even power? What do I do to get the square root of a power? Divide by 2. So that is x cubed. Is there a square root there? What is it? Plus 2, and then x cubed minus 2. Everyone cool? It's just like this one, right? But because that was an odd number, we had to factor out till we got an even number. Is everyone good there? Okay, now the very last one. The very last thing I can do with this. And it's going to be freaky, but you're going to be cool with it, okay? This will be number 6, 7, 8. This will be number 9. X plus 3 squared minus x minus 2 squared. Now just stop and look at it for a second. Is that a perfect square? Yes. Is that a perfect square? Yes. Are they subtracting? Yes. So can we use square root plus square root minus square root? Excellent. Now, you guys already should have noticed from doing a couple of these substitution ones that the a is just this, isn't it? And we ended up writing it down here, didn't we? So what can I make that? A. Now, is that the same? So what do I have to make it? I have to make it a different letter. Oh, it wouldn't matter. I could make it J, right? So what is the square root of a squared? It would just be a, wouldn't it? So a plus b, yes? And then what would I write? A minus b. But are there really a's and b's in this question? No. What is a really? X plus 3 plus x minus 2, right? Okay, now I'm sensing there's a little bit of hesitation now. Tasha. Because I'm taking the square root. We have never put the exponent in. It's square root, right? Okay, and that's one side. Then I got to write this again, but instead of plus, what do I write? X plus 3 minus x minus 2, yes? Okay, what is x plus x? No. No. 2x. And what is 3 minus 2? 1. Positive 1. Is everybody cool? Okay. What is x minus x? Nothing. X take away x is 0. What is 3 minus 2? 5. And now that one's done. And that's the hardest thing I can do with difference of squares. If you know everything up to there and that's the only thing that's confusing you, you've got a B plus A minus level of understanding. If you need to see one of them again and bigger, I can do another one just to make sure. Okay. All right, let's do one more one. All right. Let's make it a little bit harder, but the same principle. Okay? Let's go with 3x plus 7 squared minus 2x plus 3 squared. It's up to you. If you feel you need to write it down somewhere where you have some space. If you just want to watch and make sure you're thinking right, then just watch and make sure you're thinking right, because it is recording. Okay? So, if you wish, you could make these A and B, yes? Which means what I have there is A squared minus B squared, yes? Which means I have A plus B, A minus B. Is everyone okay to there? That's the grade 10 stuff. Okay? That's grade 10. If you can get to there, you're in good shape. Now we're going to use some knowledge we have from grade 9. What is A? 3x plus 7. And that's all one thing, yes? Then I'm adding B. What's B? 2x plus 3. Is everybody cool? Okay. Then I'm going to do that again, but instead of 3x plus 7 plus 2x plus 3, what is it going to be? 3x plus 7 minus 2x plus 3. Correct? Now, what? Now, this is where grade 9 comes in. You got to know your grade 9 stuff. What can I do with 3 x's adding 2 x's? 5 x's. Is everyone okay? Okay. What do I do with positive 7 adding positive 3? Plus 10. Yes? Okay. Now, let's do that over here. What do I do with 3x minus 2x? That's 1x. And what do I do with 7 minus 3? 4. Plus 4. Is everyone cool to there? Is everyone cool to there? Okay, now, I use these numbers on purpose because something happened at the end. How many of you want to stop right now? Well, you know me, right? You know that when I say how many of you want to stop, the answer is no, there's more. But really, if I hadn't said that, how many of you are comfortable with us being done? Okay, now I want you to look closely at that. What do you notice about 5 and 10? There's a GCF, isn't there? So what can I do here? Divide by 5. So the 5 comes to the front. And what's this? X plus 2. And then x plus 4. If you get to there, I am this happy. If you get to there, I am this happy.
Tongue's just flying out and everything. Whoa.
Okay? All right? If you want this, you got to remember that last little step. But if you don't, I'm still pretty dang happy. Picking up what I'm putting down?
Yeah.
Riley.
Instead of dividing that by 5, I thought you were going to do 5x times x.
You thought you were going to expand it. See, that's where you guys get messed up. You see more math that could happen. But if I expanded this, I would end up with this. Again, you just go in a circle, right? If I was just using numbers, think about it. If I told you to tell me the factors of 24, you would tell me two numbers you could use would be 8 and 3, right? I only wanted the factors, so the answer is 8 times 3, right? But if you just start, I got to do math. Okay, 8 times 3 is 24. But I already knew about the 24. I was looking for what built up to 24. You picking up what I'm putting down? So that's what I'm trying to say. Only do what you need to do, and don't get flustered and think there's more to do. All I wanted was factors. Is this factors? Is that something times something? So you've got your factors. I'm happy. Okay? Now, like I say, you could go one step further because that breaks down. But again, that's only the difference between and this. Okay? It's not a big difference. It's not a big difference. Trust me, I'm the one in my brain. It's not that far. I'm a pretty happy-go-lucky guy. All right. Is everybody good? Okay, so here's what I want for you guys to do. Today, I want you to do... Now, did I say give 134 a try yet? No. Do that now. Now, most of 134 is what we just did, but I threw a couple in there from before to keep it fresh in your mind. Okay? So 134 is mostly what we just did, but you'll notice down at the bottom there's some of the ones from 2 days ago, 131 and 132. Okay? Huh? I'd like to see it done pretty darn soon. Tell you what, I'm not doing anything new today, but by the end of tomorrow, I lie, by the beginning of tomorrow, I want you done up to 136. So you got the rest of today and tonight to do 134, 135, 136. Now you will notice that I am giving you a crap ton of practice here, right? Because let's be honest, once you get in the groove of this, it's really easy, right? It's not like the other math we've done. This is like, boom, multiply to this, add to this, boom, square root there, add, minus, done, right? Go.